4.1b, antiderivatives and indefinite integrals, part 2. All right, this first one, we have the integral of sine x over cosine squared x. Right now, we don't have enough information to do it different ways. So, right now, how many cosines do we have on the bottom? 2. I felt like I said that already. All right, and then, so what do? We actually need to split up this integral. So I want to think of it as 1 over cosine and sine over cosine. See how we just split that up? You see how we just rewrote it or manipulated it? You see that? All right. And so what is 1 over cosine x? Secant x. And then what is sine x over cosine x? Tangent x. And so now I have the integral of secant x tangent x. So now I can basically find, well, if I took a derivative of something and I got secant x tangent x, what did I actually take a derivative of? Secant. And so this is just straight up note card. So I have secant x and then plus c. All right, because we don't know our vertical shift going on. All right, so this one's very similar to Riley's number 27. So I have x plus 1 over square root x. I can't integrate it with it looking like this right now. So what could I do? Distribute dividing. So now I have x over square root x, which is just what? X to the 1/2. All right, or square root x, but we kind of think of it in these fractional exponents right now. And so then I have 1 over square root x, which is what? X to the negative 1/2. All right, and so we basically need to distribute our dividing and rewrite it like this. So now if I antiderive these, x to the 1/2, if I antiderive that, I'd have x to the 3/2. I add a power, and then I divide by it, but really I'm dividing by a fraction, so I do what? Multiply by its reciprocal. So now I have what out front? 2/3. And then I have x to the negative 1/2. I want to antiderive that, so now I have x to the 1/2. And then what do I do with that 1/2? I multiply by 2. All right. And so now I have plus c because it is indefinite. We don't know our vertical shift. All right, let's keep going. So now I have f. I need to find f given f prime. So f prime of x is equal to x square root x. And then I'm given something else. I'm given f of 1 is equal to 2. And let's see if Nolan remembers what this is called. He better. What is this f of 1 equals to? An initial condition. This is our first time seeing it. And we're going to be seeing it a lot. Right? So now what we're given is called an initial condition. It's basically going to tell us our vertical shift going on. So it's not going to be a general solution anymore. It's going to be what's called a particular solution. All right. So I'm given f prime, but before I do anything, I want to rewrite what that f prime looks like. So what would that f prime look like?
X to the 3/2.
There it is. So now, how do I get from f prime to f? What do I need to do? Take an antiderivative, take an integral. All right, so f of x would equal what? X to the what? 2/3 x. X to the 5/2. But what comes out front? A 2/5. All right, so now I have 2/5 x to the 5/2 plus c. All right, now that is where we stopped from the other day. That's kind of where we stopped. I need to keep going because I'm given it an initial condition now. I can actually solve for freaking c here. So if this f of 1, this 1 represents my what value? X, and this 2 represents my y, or my f of x value in this case. So now I have 2 is equal to 2/5 times, what's my x value? 1. And then I have to the 5/2 plus c. Well, 1 to the 5/2 is what? 1. 1 times 5/2, or 2/5, I'm sorry, is what? 2/5. So now I have 2/5 plus c is equal to 2. How would I think of 2? 10/5. So now I have 10/5 minus 2/5, which is how many? 8/5. So c is equal to 8/5. Now I take this and I back substitute it back here. So now, what is f of x? 2/5 x to the 5/2 plus 8/5. So now I know my particular solution. I know my vertical shift of my actual function. Pretty nifty? All right, but I have to be given an initial condition in order for that to happen. All right, do it again. So now I'm going to find f, or f of x, given f double prime. And f double prime here is 12x squared plus 6x minus 4. And now I'm given two initial conditions. Now I'm given f of 0 is equal to 4, and f of 1 is equal to 1. Well, if I need to go from f double to f, how many integrals am I going to take? Or antiderivative? I'm going to take 2. All right. All right, so let's do 1. So if I need to go from f double, I need to get back to f. The first thing I need to do is get to f prime. So what is the antiderivative of 12x cubed? Or 12x squared, I'm sorry. 4x cubed. All right. And then what's the antiderivative of 6x?
3x squared.
3x squared. And then what is my antiderivative of negative 4? Negative 4x. And then what do we need? Plus c. Now, are any of these initial conditions going to solve for c for me right now? No. Okay? Because both of these have to do with what? F. Now, there are multiple ways that you can see this kind of problem. Sometimes they give you an initial condition with f prime and f. So if let's just say for kicks and giggles, if this one was f prime of 0 is equal to 4, could I solve for c right now? Yes, I sure could. However, this one is not that way. You will have some of those on your homework though. All right, so now I need to get back to f. So f of x would be equal to what? What is my antiderivative of 4x cubed? X to the 4th. That's convenient. And then plus what? X cubed. And then what?
Negative 2x.
Minus 2x squared. Now, what is the antiderivative of c? Cx. Exactly. Very good. And then plus, I'm going to call it d. Now, on your textbook, if you look in Calc Chat, they're going to call this first one c subscript 1, and then what I call d, they're going to be calling it c subscript 2. I don't like that notation. I personally don't. I don't want to do that. All right? But you can't call them both c's because that would be the same variable. You following me? So what I usually do is I use c and then I use d. All right? Because d comes right after c. All right? That's what I usually make it. All right. So here we go. Now I need to use my initial conditions. I use f of 0 equals 4 and f of 1 equals 1. There's one choice that's better than the other. Which choice is better than the other right now? The first one. F of 0 is equal to 4. That is the better choice right now. Why?
Because all the exponents cancel out.
All of my x's go away, basically. All right, and that's what we need in real life, too. All right, so then d is equal to what? 4. So now that I have that, I'm going to substitute it back in. So now I have f of x, which is equal to x to the 4th, plus x cubed minus 2x squared plus cx plus 4. Right? Now what do? We substitute in what? The next ordered pair. So now, what is my y value or my f of x? 1. So 1 is equal to 1 to the 4th plus 1 cubed minus 2 times 1 squared plus what? How many x's? Or how many c's, I mean? 1c. And then plus 4. All right, let's do some math here. So 1 to the 4th is 1. 1 cubed is 1 minus how much?
2.
2. So those go away. So that's awesome. So I have c plus 4 equals 1. So c equals what? Negative 3. So c is equal to negative 3. So now negative 3. I even said negative 3, didn't I? And so now I'm going to take that and I'm going to substitute it back in. So now f of x is equal to x to the 4th plus x cubed minus 2x squared minus 3x and then plus 64. And so that is my particular solution given those two initial conditions. All right, pretty cool? All right, it's not general anymore. All right, read my problem.
I was off by a
lot.
9,000.
It's 1,000 patents.
On the dot.
No, 1,093.
Okay, that makes some more sense. All right, here we go. We're recording, TJ. Here we go.
Wizard of Menlo.
A ball.
Read, bro.
Oh, I'm reading?
Yes.
But it's not about us.
This is like 21 seconds in now. All right, here we go.
A ball is thrown upward with an initial velocity of 64 feet per second. What?
You're good.
Read, bro.
From an initial height of 80 feet. Find the position function giving the height as a function of the time t.
All right, fantastic. Thank you so much. So we're given an initial velocity of 64. So that is v of 0 is 64. That is an initial condition. The other initial condition is what? A height of 80. So we're going to call that s of 0 equals 80. Those are the two things that were given to me. Now, part A says find the position function s. All right. Well, what do we know? We know our constant acceleration is what? And I don't want meters per second squared. Does anybody remember?
It's like 30 feet.
Negative 32. All right. It's negative 32 feet per second squared. It's not negative 9.801. That's not what I want here. All right. Here we go. I need acceleration, and I need to get back to what? Position. So let's take an antiderivative. So my antiderivative of acceleration is what? Velocity. So v of t is equal to negative 32t plus c. Well, I have an initial condition of v of 0 equals 64. So what did that solve for? C. So C is equal to 64. So I'm going to back substitute it. So now my v of t equation is what? Negative 32t plus 64. Well, now, what do I need to get to? Position. I need to get to position. So what do? Take an antiderivative. So s of t is equal to, what is my antiderivative of negative 32t? Negative 16t squared plus 64t plus, no.
No.
You got to use another variable. We already used c. Does that make sense? All right. You can't use the same variable. All right. So now we have an initial condition. So what did we basically solve for?
The d.
D. D is equal to 80. And I'm going to take that and I'm going to back substitute. Now, they don't have to say your initial height. They could say at time 1 we get something. Do you follow me? All right, so don't just think that number that they give to you is what we're going to have for a constant. All right, so we have 80 there though. So now I have my position, s of t is equal to negative 16t squared plus 64t plus 80. All right, so that's part A, fantastic. Part B. Edison, go.
Oh. When does the ball hit the ground?
All right, fantastic. So what do we need to do with our ball hitting the ground? What do we do?
Set to 0.
Set what equal to 0?
S of t.
S of t, very good. So we're going to set s of t equal to 0. So now 0 is equal to negative 16t squared plus 64t plus 80. Now, this one's really nice. I don't even need a calculator for it. I have a quadratic. What could I do to that?
Take
I
out.
could F it up. This one actually works nicely. All right. So what could we factor out?
Negative 16.
Negative 16. So now I have t squared and then what?
Minus 4.
Minus 4t and then,
Plus 5.
not plus, but minus 5. All right. So now I have this really simple quadratic, and what does that F up to? T minus 5 and t plus 1. So what are my answers? I get t equals what? 5 and t equals negative 1. Which one doesn't make sense?
Negative 1.
-1. We're not going back in time. All right. So this one is called what, TJ?
Extraneous.
Extraterraneous.
All right, fantastic. So when it hits the ground is at 5 seconds. That is my answer. Now, they could go further in asking questions. They could say, what is the velocity when the ball hits the ground? What would we have to do?
Plug in 5 seconds.
Dear
and
goodness.
velocity.
What would we have to do?
Substitute.
Substitute in 5 into velocity. All right. Here we go.
At the instant the traffic light turns green, a car that has been waiting at an intersection starts with a constant acceleration of 6 feet per second.
All right, so what about my car? My car does what? What do we know about it?
It's electric.
My acceleration is what? 6. All right. My acceleration of my car is 6. All right, keep going.
At the same instant, a truck traveling with a constant velocity of 30 feet per second passes the
All right, so what do we know about my truck?
B.
My V is what? 30. All right, keep going.
How far beyond its starting point will the car pass the truck?
All right, fantastic. So what do we need to get back to? How far beyond? What do we need to get to?
Distance.
We need to get to position. All right, we need to get to the position function. Once we get to that position function, what do we have to do with those two position functions? Set them equal. Exactly. All right, so let's take some antiderivatives. So I notated it by acceleration of the car of time. So I do have some subscripts going on. So what is my velocity of my car? What is my velocity of my car? 6t. Now, it's technically 6t plus c, but what do we know my initial velocity is? 0, because that car's chilling. All right? He's chilling at the stoplight. And this problem is quite terrifying, actually. Because if the car is chilling at the stoplight and the truck is at 30 feet per second the entire time, did that truck actually slow down at all?
No, he was
going
going to
into
pass the red line.
Okay, he timed the red light. He was timing it. All right, good old trucker. He lives on the north side. All right, so then, what is my antiderivative of velocity? Position. So now I do my position of my car is equal to what? 3t squared. All right. Now I need to get to position of my truck. Well, what's the position of my truck? Which would be what? 30t. Now, what do I want to do with those two functions? I want to set them equal. So now I'm going to set 3t squared equal to 30t. Now, I personally am going to subtract to go to the other side so I can prove something a little bit so I don't actually get rid of a t. So now I have 3t squared minus 30t equals 0. So what could we factor out?
3.
A 3 and a t. So now I have 3t and then times what? T minus 10. So I get t equals what? 0 and t equals 10. So this kind of makes sense, right? I have t equals 0 because that's when they start out. They start out at the same position. And then t equals 10, that's when the car is going to actually pass the truck again. All right. So what do we need? Have I actually answered the question yet, though? No, I found out how long it took, but I want what? How far beyond? So what do we need to substitute it back in?
Distance.
My distance. Now, on this one, is it actually going to matter?
No.
No. So S of 10 would be equal to what? 300. What are my units? Feet. All right. All right, let's look at part B. Skipper.
How fast will the car be traveling when it passes the truck?
All right, how fast will it? So what do we actually need to get to? Speed, but in this case, it's going to work out nicely.
30.
We need to find velocity of what? The car. We need to find the velocity of the car. So we need to find the velocity of the car at 10 seconds. And so what would be the velocity of the car at 10 seconds?
60 feet.
60 feet per second. All right. Enjoy.